So this is chapter 4 of MYP4 Unit 1, solving quadratics by factorization. So last time round in chapter 3 we looked at how we expanded brackets. So for example, x plus 2 times x plus 3, we did x times x gave us the x squared, x times 3 from the first and second brackets, and then 2 times x gave us 3x plus 2x, which came together to make 5x, and then 2 times 3 gave you the 6. So you got a quadratic function, or a quadratic expression, x squared plus 5x plus 6. And the 5 basically came from the 3 plus the 2, because we did 2x and 3x and put them together. And then the 6 came from the 2 times the 3, because we multiplied the 2 times, or the 2 by the 3 at the end to get the 6. So factorization is all about trying to do what we just did, but the other way. So instead of taking two brackets and multiplying them out to get an expression, we've got the finished expression and we're trying to put it back into two brackets. So if we wanted to get from x squared plus 5x plus 6 and put it back into two brackets and figure out what numbers needed to go in there, we'd need to think of what factors of 6 could be paired up. So 1 times 6 could give us a 6, or 2 times 3 could give us a 6, and think of various combinations that will give us a 6 at the end when you multiply two numbers together. But then out of all the possibilities for that, which ones of those will give us two numbers that add up to 5 as well? So we need to think of factors of 6 that add up to 5. So for example, here's a question, factorize x squared plus 17x plus 66 back into brackets. So we need to think of factors of 66, two numbers that will multiply to give you the 66, but then they need to add up to 17. So factors of 66 that add up to 17. So what I've done is systematically gone through all the possibilities and made a comprehensive list and then considered them one by one. So factors of 66 could be 1 times 66, but then they add up to 67, so that's no good for us because we want them to add up to 17. 2 times 33, that would give us 66, but then 2 and 33 add up to 35, so that's no good. 3 times 22, that makes 66, but 3 and 22 add up to 25, so that's no good for us because we want them to add up to 17. And then finally we got there 6 times 11. 6 times 11 is 66, so that's factors of 66, and then 6 plus 11 adds up to 17. So factors of 66 that add up to 17 are 6 and 11, so they are the numbers that go in the brackets. X squared plus 17x plus 66 is equal to x plus 6 times x plus 11. And then of course you could just verify that if you want to by going the other way again and multiplying these brackets out, and then you'll get x times x will give you the x squared, x from the first bracket times 11 from the second bracket, and then 6 from the first bracket times x from the second bracket will give you 11x plus 6x, and together they'll make 17x. And then finally the 6 times the 11 will give you the 66. So in class we did 4 questions, and then if you haven't done them, I suggest you pause screen now and try and do them, and then the answers are coming up. Okay, so I hope you paused, and here come the answers. So question 1, x squared plus 15x plus 36. We need factors of 36 that add up to 15. So I systematically went through, starting with 1 and then 2 and then 3, and then considering all of the numbers that could be used to make factors of 36. So 1 times 36, or 2 times 18, 3 times 12, 4 times 9, nothing with 5 because 5 doesn't go into 36. 6 times 6 makes 36. And then if I kept going up there, then the next one I'd get to would be 9 times 4, but I've already done 4 times 9, so I'd just kind of be going backwards down the same list. So those are the possible factor pairs, and then only one of those pairs adds up to 15, and that's when you have 3 and 12. So the numbers that go in the brackets are 3 and 12. So x squared plus 15x plus 36 is x plus 3 times x plus 12. Second one, x squared plus 12x plus 32. So factors of 32 that add up to 12. So I went through all the possible factors of 32. 1 times 32, 2 times 16, 4 times 8. The next one would have been 8 times 4, but I've already got that really. And then I've got 2 that add up to 12. So 4 and 8 add up to 12, and they multiply to give 32. So 4 and 8 are factors of 32 that add up to 12. They are the numbers that go in the brackets. And x squared plus 12x plus 32 is equal to x plus 4 times x plus 8. So going back to the questions here, question 3, you've got a couple with minuses, so you've got to be a bit careful with those. So you're looking for factors of minus 72 that add up to 6. Whenever you see a minus number, it belongs to the thing that comes next. So 2 factors of minus 72 that add up to 6 would be 12 and minus 6. 12 times minus 6 makes minus 72, and 12 plus minus 6 makes 6. So your numbers in the brackets, or your brackets, are going to say x plus 12 and x minus 6 for that one. And then number 4, again tricky with minuses. You're going to have 2 numbers that multiply together to give 80, but then add up together to give minus 18. So you're looking for factors of 80, 2 numbers that multiply together to give 80, but add up to minus 18. So there's got to be minuses in there somewhere to get the minus 18, but they've got to multiply together to give a plus. So in fact, they've both got to be minus numbers, and you're going to have minus 8 and minus 10. Minus 8 times minus 10 gives you plus 80, because minus times minus makes plus. And then minus 8 add minus 10 gives you the minus 18. So your brackets for this one are going to say x minus 8 and x minus 10. Here's another tricky one. X squared minus 25. Now you notice there's no x term, unlike the previous examples. So it's like having 0x. So think of that as x squared plus 0x minus 25. So you need factors of minus 25 that add up to 0. So two numbers that are factors of minus 25 that add up to 0 would be 5 and minus 5. So x squared minus 25 would be x plus 5 times x minus 5. And then a similar one might be x squared minus 9. So two factors, or two numbers that add up to 0 but multiply to give minus 9. And that would be plus and minus 3. 3 and minus 3 add up to 0, but when you multiply them, they give you minus 9. And then another example of that type, x squared minus 16. So you'd be looking for two numbers that multiply together to give minus 16, but add up to 0. So that would be 4 and minus 4. When you put 4 and minus 4 together, they cancel each other out, and you get 0. So 4 plus minus 4 is 0, but then 4 times minus 4 is minus 16. And they're all of a particular type. These are all x squared minus something that happens to be a square number. 25 and 9 and 16 are all square numbers. So The general form is this: x squared minus some number squared is equal to x plus a number times x minus the number, and it's the number in the brackets here, plus and minus, that this number here is the square of. Okay, so it's probably easier to recognize just looking at the specific examples than the general form, but do look out for that, because that is quite a common question that you can see on exams from time to time. Okay, well, now that we know how to factorize quadratic expressions, we can use that to solve quadratic equations. So if you see a quadratic expression, something with x squared and x's and a number on the end equal to 0, you can figure out what value of x will make that balance. So if we start off with x squared plus 14x plus 24 equal to 0, we want to solve that. We want to figure out what value of x will make that equal to 0, and so make the whole thing balance. So we can factorize it, and you can pause the screen and do the whole list if you like, but I'll tell you that it factorizes into x plus 12 times x plus 2. So factors of 24, 12 times 2, and they add up to 14. So saying that x squared plus 14x plus 24 is equal to 0 is the same as saying that x plus 12 times x plus 2 is equal to 0. It's just another way of writing the same thing. Now, if you think about multiplying two numbers together to get 0, 5 times 0 is 0. 100 times 0 is 0. 0 times 100 is 0. 1,584,386 times 0 is 0. 0 times 1.84 is 0. Anything multiplied by 0 will give you 0. So what we've got here are two brackets multiplied together that have to be equal to 0. So the whole thing will come out to be 0 if either of those brackets that we're multiplying together is itself equal to 0. So x plus 12 times x plus 2 will be equal to 0 if either the first bracket is 0, x plus 12 is 0, or if the second bracket is 0, so if x plus 2 is 0. So for x plus 12 to be 0, x would have to be minus 12, and for x plus 2 to be 0, x would have to be minus 2. So x equals minus 12 and x equals minus 2 are both numbers that will make this whole thing come out to be 0, and then logically working backwards, therefore they'll make that whole thing come out to be 0. And the good thing about algebra, of course, is that you can go back and check things. So I can take both of these numbers and stick them back in there and see that I do indeed get 0. So in fact I did that. When x equals minus 2, x squared plus 14x plus 24 becomes minus 2 squared plus 14 times minus 2 plus 24, which is 4 minus 28 plus 24, which is 0. So far so good. And then when x equals minus 12, so you've got x squared plus 14x plus 24, which is minus 12 squared plus 14 times minus 12 plus 24, which comes out to 144 minus 168 plus 24, which is 0. So that's exactly what we were expecting to happen. So here's some questions that we did based on that. Pause the screen, have a go at them. There's a little tricky one at the end. Most of these are equal to 0, but then the last one is something equal to 28. So we can't use the thing about two numbers multiplied together being 0 if we've got a 28 there. So we need to think about doing something to that first, to both sides, so that we get something that looks like the other questions. So pause the screen, have a go at those, and answers coming up. Okay, so answer 1, x squared minus 10x plus 24 equals 0. So you're looking for factors of 24 that add up to minus 10 in order to factorize that. So I did a comprehensive list of them. 1 times 24, 2 times 12, 3 times 8, 4 times 6, but then also minus 1 times minus 24, minus 2 times 12, minus 3 times 8, minus 4 times 6. I needed to think about those minus possibilities in order to get the minus there. And then the one that works is minus 4 and minus 6. So in the brackets, we get x minus 4 times x minus 6 is 0, and that will be 0 if either of the brackets is 0, so if x is 4 or if x is 6. Question 2. X squared minus x, so that's like minus 1x, minus 56 equals 0. So we need factors of minus 56 that add up to minus 1. So again, I did a comprehensive list of all of the possibilities, and then I got two numbers, 7 and minus 8. They multiply to give minus 56, they add up to give minus 1. So the numbers in the brackets are 7 and minus 8, so x plus 7 times x minus 8 equals 0. So the numbers that will make the brackets 0 are minus 7 and plus 8. So the solutions are x equals minus 7 and x equals 8. That's something that confuses people a bit, because they see the plus 7 and then the minus 8 in the brackets, but then it sort of seems to flip round when it's the answer, and then the minus is with the 7 and then the plus is with the 8. But remember, you're thinking about making the brackets equal to 0, so x has to be minus 7 to make the whole bracket x plus 7 0. Number 3, x squared minus 169 equals 0. So that's a bit like having, well, that's exactly like having x squared plus 0x minus 169 equal to 0. So having no x term there is like having a 0x. So you're looking for factors of minus 169 that add up to 0. There were only three possibilities to think about. 1 times minus 169, 169 times minus 1, and then 13 times minus 13. So the ones that add up to 0 are 13 and minus 13. So that factorizes into x plus 13 times x minus 13. And remember, I talked about that general form where you've got x squared minus a square number. So x squared minus 169, which is 13 squared, factorizes into x plus 13 times x minus 13. So to make either of those brackets 0, x has got to be minus 13 or 13. You'll notice how we're getting two possible answers for most of these. So that's normal for quadratics. You can get up to two possible answers. You never get more than two. Sometimes you only get one. Sometimes there aren't any possible answers at all. And then question 4, x squared plus 18x plus 100 equals not 0, but 28. So what I've done is taken away 28 from both sides and got x squared plus 18x plus 72 equals 0. So an equation is like a balance, so if you do exactly the same to both sides, you've still got something that balances. And the advantage of doing that is now that we've got something equal to 0, and we can do the thing with two brackets multiplied together equal to 0. So having written it like that, we need factors of 72 that add up to 18. I went through the whole list of possibilities and I got 6 and 12. So that factorizes into x plus 6 times x plus 12 equals 0, and to make those brackets 0, x has got to be minus 6 or minus 12. So two possible answers, x equals minus 6 or x equals minus 12. And of course, being algebra, you could just check that answer if you want by sticking them all the way back into the original thing and making sure that you get 28 at the end, which you will do if you do it correctly. So here's a little note about graphs. The fact that x squared plus 18x plus 72 equals 0 has two solutions reflects the fact that its graph cuts the x-axis at 2 points. Because you're asking the question, when does that thing equal to 0? When is that thing equal to 0? And if you do the graph, where it equals 0 is when y equals 0 on the graph, so along the x-axis. So you'll notice that where the graph of y equals x squared plus 18x plus 72 cuts the x-axis, it crosses at 2 points. It crosses at x equals minus 6 and x equals minus 12. So those 2 points where it crosses are showing you where the solutions are, because it's where it's 0 on the graph. So you need to be aware of that relationship between the solutions of a quadratic equation and the intercept on the graph. Where it cuts the x-axis is showing you where the solutions are, because it's showing you where the function is equal to 0. Also, I've made a little point here that it cuts the y-axis at 72, and that makes sense because when it cuts the y-axis, x is 0, and when x is 0, these things are 0, so you just get the 72 there. So the fact that it cuts vertically at 72 is also related to the numbers in the original function. So we talked a little bit more about the relationship between graphs and their solutions. So in this one, for example, x squared plus 16x plus 64 equals 0. If you factorize that, you get the same thing in the two brackets, x plus 8 times x plus 8. So in this case, it only has one solution, x equals minus 8. And that manifests itself on the graph by the fact that the graph just about touches the x-axis at a point and then comes back up again. So where it's only got one solution, it's only just touching the x-axis at one point. And that point, x equals minus 8, corresponds to the solution of the equation when you equate it to 0. Sometimes you get ones that can't be solved at all. So x squared plus 4x plus 24 equals 0. Try by all means, but you can't solve that one. And looking at the graph of y equals x squared plus 4x plus 24, it never cuts the axis. So on the graph, there's no point when it's equal to 0, and you try and figure out analytically when it's equal to 0, you can't do it. So sometimes a quadratic equation has no real solutions. That's an important point. So this can't be solved, and then I've just qualified that with the statement with real numbers. As you go further in maths, you'll do things with square roots of negative numbers, and there is another system of maths by which you can achieve a solution to that, but it's beyond the scope of this that you're doing at the moment.